Okay, so this is our last thing to do in the quadratic functions and equations unit, and we're going to scale and reflect parabolas. So last time we were moving them, translating them around, just and not scaling them in one direction, not making them bigger or smaller, not reflecting them, flipping them. So, but we're going to start doing that. Again, as usual, I haven't seen these first, so I may have to read for a second to understand what's going on. So, all right, so we have f of x equals x squared and g of x equals 2x squared. So I know that if I write this as if I write this in vertex form, I'm going to have y is equal to 2 x minus 0 squared plus 0. So here my a is 2 and my b is 0 and my c is 0, right? Let me write this down here so I don't have to erase it later. Y is equal to a x minus b squared plus c. Okay, so I haven't shifted it. I haven't shifted the x squared at all here, right? I've just scaled it. So the word here we're going to, whoops. We just scale this by 2 by a factor of 2. All right, scale by a factor of 2. So that means that whatever we had before, if this is our x squared, whatever value we have here, suddenly it's double. 0 is going to stay the same. Whatever value we have here is going to double. So when we have an a greater than 1, it is going to be tall and narrow. I'll say up and narrow. Okay. Whenever we have an a that's between 0 and 1, it's going to be up, but it's going to be shallow, so it's going to open up. Everything's going to be multiplied by something that's going to be shallow. And if we have an a that's between -1 and 0, it's going to be down and shallow. And if we have an a that's less than -1, it's going to be down and narrow. And that's because we're just multiplying by -2 or -3. We're making everything go farther down. If here it goes up 1, there it's going down 3. If here it goes up 2, there it's going down 6. So what we can see is if we have an a of 2, then we're going to be going up, and it's going to be narrow. So my g should look like that. Let's look at some of the others. This one is open more. So this one, a is going to be less than 1. Still positive. It's going up, but it's going to be less than 1. So whatever value I have here, I'm taking half of it. This one, I'm taking half, we'll say. This one is negative, and it's down. It's like it's more narrow. So it's greater than. Sorry, it's less than -1. And this one is shallower. So it's between 0 and -1. Well, we can see this is definitely our answer. Okay, function g can be thought of as a scaled version of f of x equals x squared. Write the equation for g of x. Okay, so So we can see that f of x is equal to x squared, and I know that f of 1 is equal to 1. 1 squared is equal to 1. Excuse me. But I can see over here g of 1 is equal to 5. And I know that 5 is 5 times 1, or 5 times f of 1. So I know that g of x here is scaled as 5 times f of x. But f of x is just x squared, so that's 5x squared. Well, let me go ahead and write that down. 5x squared. And let's find a new piece of paper here. The parabola y equals x squared is scaled vertically by a factor of 5 over 2. I'm going to write the vertex form again, which is a x minus b plus c. A is where we scale by a factor of, okay, and b is move in the positive x direction by how much, and c means move in the positive y direction by how much. So we can see here we're not moving, so for our new one, b is going to be, b is going to be 0 and c is going to be 0. A is scaled vertically by a factor of 5 halves. So our a is going to be 5 halves. So we can write the general form as 5 halves x minus 0 squared plus 0. Then when we get rid of these zeros, simplify here, we'll get, let me do that, x 5 halves x squared. So y is equal to 5 halves x squared. All right, I hope that, oh, we have one more. I thought I was done. Hello, Dan. Okay, so we have one more. We can see that we've got a multiplier there. We've got a scalar. So let me just remind you, y is equal to a x minus b plus c. A means we're scaled by some amount. B means we move in the positive x direction by some amount, and c means we move in the positive y direction by some amount. So here you can see, again, b is 0 and c is 0, but a is negative 2. And so if we look back over here, and I'm going to see if I can bring this up over here. There we go. It's a new thing. Can I drag this? Oh, I can drag it. Okay, this is a new program for me. So we'll see that if our a is greater than 1, we're going up and narrow. If our a is between 0 and 1, then we're going up, but we're going shallow. So it's like that, or like that, or if it's between 0 and 1, it's a fraction, basically. I mean, not a rational number. It's a fraction that's between 0 and negative 1, then we're going down shallow. And if it's less than negative 1, then we're going to be going down and and narrow, and we can see it's -2, so it's -2, so it's definitely going to be down and narrow. This one is up and narrow, so a is greater than 1 on that. This one is up and shallow, so it's a is between 0 and 1. This one is down and narrow, so a is less than -1. And this one is down and shallow, so a is between 0 and -1. Okay, that was just kind of an introduction to translations. We'll be doing translations in I think Q3 this year. But we'll use all the same kinds of concepts, so I want you to kind of get used to it, and then we'll start doing it with other polynomials and with circles and some other things like that. We'll be doing transformations that way.